You know, every so often, a new machine learning framework pops up that makes you go, that's interesting. Well, today we're talking about one of those. It's called ZML. And the premise? It's a really compelling one. What if you could just ditch Python and build your ML models with the raw power and, the beautiful simplicity of the Zig language? It's a great idea on paper, but as we're about to find out, ZML is kind of having an identity crisis. It's caught in this tug-of-war between the big, easy-to-use frameworks and the super low-level, gritty code.
So here's how we're going to break this down. First, we'll look at the dream, what ZML promised to be. Then, we're going to see how that promise holds up when it meets reality. From there, we'll get into its awkward middle ground problem, map out a few ways it could actually gain some traction, and finally, we'll land on a verdict about its future.
All right, let's dive right in. Section 1, Meet the New Contender, ZML. When this first appeared, the buzz was pretty real, and that's because it felt like a genuinely fresh take on how we do machine learning.
So, what is ZML exactly? Well, at its core, it's a machine learning inference framework written completely in Zig. Now, if you've ever worked with Zig, you know it's all about simplicity, control, no hidden stuff happening behind the scenes, and the idea of bringing that clean, powerful philosophy into the often chaotic world of ML, well, that's what got people really excited. And this right here, this quote gets to the absolute heart of the dream. Imagine a world with no more Python dependency hell. A world where your model runs the exact same way every single time. That's the deterministic part. And a world where you feel like you have direct, low-level control over what's happening. I mean, for anyone who's ever battled a complex ML pipeline, that sounds less like a framework and more like a vacation.
Okay, but this is where that perfect story hits a bit of a speed bump. In Section 2, we're talking about what happens when developers actually popped the hood and started taking a look at the engine. Turns out, the reality wasn't quite as clean as the brochure made it seem.
The expectation, the hope, was for pure simplicity. You'd use Zig's famously elegant build system, run one clean command, and boom, your model compiles. No fuss, no mess, just pure Zig. But then reality hit. To handle these absolutely enormous C++ dependencies like MLAR and OpenXLA, ZMLA has to use Google's Bazel build system. All of a sudden, that beautiful, simple Zig experience is tangled up with a completely different and, let's be honest, famously complex toolchain. Not quite the dream.
And this slide reveals the big twist in the story. Look at this. Both ZML and Google's very popular JAX framework, they're both using the exact same OpenXLA compiler on the back end. This is so important. It means ZML isn't some revolutionary new compiler. It's basically a Zig skin on top of the JAX engine. The only real difference is the language you're writing.
And that actually creates this kind of ironic friction. You see, the very things that make Zig a brilliant language for systems programming, like not having operator overloading to hide complexity, can make writing ML code feel pretty awkward. A simple x plus y in Python suddenly becomes a longer, more verbose function call in Zig. Now, imagine scaling that up to a whole neural network. The code can start to feel clunky and honestly just harder to read.
Which brings us right to Section 3, ZML's identity crisis. It's stuck in this really awkward middle ground, and it's not quite fitting in anywhere in the modern ML world. So yeah, it really begs the question you see on the screen. Where does ZML actually fit? Is it trying to be this high-level, easy-to-use thing, or is it a low-level, high-control tool? Let's take a closer look. This table just lays it all out perfectly. Just look at ZML sitting right there in the middle. If you compare it to JAX on the left, you're giving up this massive Python ecosystem for what? And then you look over at llama.cpp on the right, that's a truly low-level, high-control tool. But ZML doesn't give you that same granular control either, because everything's hidden behind that big compiler. It's the classic jack-of-all-trades, master-of-none problem. Which leads us to I guess you could call it the billion-dollar question. ZML is asking you to abandon Python's enormous, mature ecosystem. We're talking all the libraries, the tools, the community support, everything. So, what's the payoff? What do you actually get in return for making that huge sacrifice? And the honest answer right now is, we have no idea. We literally can't know. And that's because, as you see here, the single most important piece of the puzzle is missing. There are no public benchmarks. There is zero data to prove that giving up the entire Python world gives you better performance or faster inference or, well, any concrete advantage at all.
But look, this isn't meant to be a takedown. ZML is still a young project, so in Section 4, let's switch gears from problems to solutions. Because there actually is a pretty clear path forward for ZML to find its niche and, prove its worth.
And that path really boils down to these 3 concrete steps. First,
Just publish one benchmark. That's it, just one. Give the world a single, undeniable reason to pay attention. Second, build a Python wrapper. This is huge because it lowers the barrier to entry to basically zero. It lets people play around with ZML without having to commit to learning a whole new language and a new build system. And third, add an Einsam API. This is all about making developers' lives easier, making the code more expressive, and making it simpler to port existing models over.
So we've seen the promise, we've waded through the messy reality, and we've laid out a path forward. That means it's time for our final section, the verdict. Where does ZML stand today, and what could its future actually look like? I think this quote just perfectly captures the entire dilemma. ZML is asking developers for a huge investment. Learn a new language, learn a new build system, and leave behind an entire ecosystem you're comfortable with. And in return, the box of benefits is, for now, pretty much empty. It hasn't shown the world that one killer feature or that one benchmark win that makes the whole sacrifice feel worth it.
And so we're left with this final question. The idea behind ZML, the core concept, is genuinely cool. But to survive, it has to make a choice. It has to prove its value. Will it carve out its own unique identity and actually deliver on its promises? Or is it going to remain just a fascinating what-if, stuck forever in that awkward middle ground? As we've seen today, the answer to that question might just come down to a few good benchmarks.